Ohm's law is one of the most important laws in all of electronics. It relates current, voltage, and resistance. With Ohm's law, you can do a lot of simple circuit design and analysis, but never memorize Ohm's law. It's very simple to derive, and let's do that now. Let's take a battery that has a voltage V, and we'll connect the plus terminal to a resistor, and we'll connect the negative to the other end of the resistor. So this is negative terminal, positive terminal, resistor R. Let's ask ourselves, what is the current in the circuit? The current flows from plus to minus. Now, in reality, the charge is really negative and flows from minus to plus. But the conventional current is always assumed to flow from plus to minus, because when they came up with that convention, they didn't know that electrons were negative charge carriers. So your circuits will work just fine if you think of current as flowing from plus to minus. So let's get back to Ohm's law, and let's see if we can figure out what current is. How does current relate to voltage and resistance? If I increase the voltage in the circuit, I've increased the electrical pressure. It's like the pressure in a garden hose that's filled with water. As that pressure increases, I have more water flow in the hose. So as voltage increases in this circuit, I have more current flowing. So there's a direct relation between current and voltage. So voltage goes in the numerator, which means as voltage increases, current also increases. But as resistance increases, we have more resistance to current flow. So as resistance increases, the current decreases. So there's an inverse relationship between resistance and current. So resistance goes in the denominator. For example, if we have 1/2 and we have 1/4, here the denominator becomes larger, it goes from 2 to 4, but the overall result becomes smaller. And we call that an inverse relationship. So let me erase this. If you ever forget Ohm's law, just remember solving for current. Now, in our simple circuit, if we increase the voltage, we increase current. So we have a direct relationship. Voltage goes in the numerator. If we increase the resistance in the circuit, current goes down. So it's an inverse relationship. Now we can represent Ohm's law in terms of voltage. Let's multiply both sides by resistance. And our R's cancel. And we're left with voltage is equal to current times resistance. So think of a resistor. We have a certain current flowing through the resistor. Let's say 1 amp. And let's say we have 1 ohm resistor. So 1 amp times 1 ohm gives us 1 volt. If we have 2 amps, we have 2 volts across the resistor. If we increase the resistor from, say, 1 ohms to 2 ohms and 1 amp, we have 2 volts. If we have, instead of 2 ohms, if we have 4 ohms times 1 amp, we have 4 volts. So just picture in your mind what's happening and get a feel for what's going on. Get a feel for this equation. Don't try to memorize it. Now we can take this equation and we can solve for the resistance. If we divide both sides by current, we get the resistance is equal to voltage divided by current. Let's think about that just a little bit. if we have a resistor, say we don't know what it is, but we have an ammeter here, and we measure a current. We have a voltage that we can measure across the resistor with a voltmeter V. And let's say that we measure very little current. So if we have little current, we know that the resistor must be large. So we can say resistance has an inverse relationship with current. But if we have a small current and a large voltage, well, then we're going to have a large resistor. So the voltage would be a direct relationship. So don't try to memorize Ohm's law, but be able to derive it and think about it. Think about the circuit and what's happening. So a large resistor means little current. An infinite resistor would be zero current. So if I is equal to 0 in this case, V divided by 0 equals an infinite resistance or an open circuit.